So far, we have discussed about the approaches to define a thread. So how many approaches we discussed? There are two approaches, right? What is the first one? Or one of them, I mean to say, by extending a thread class. By extending a thread class. And the second approach is by implementing the runnable interface. Am I correct? So which approach is recommended in these two? Is it thread class approach or runnable approach? So we discussed the benefits of using a runnable interface, where if the class which is implementing runnable interface requires another class properties, then that extend option is enabled here. It's possible, I mean to say. Then also this class at the same time can use multiple other interfaces as well. That's the reason. So this second one is uh, recommended compared to the two approaches. But in the real-time scenarios, I mean, say in real-time projects, so these two approaches will not be used. Not even first one, even not even second one. Then what is third approach? So for that, there is a third approach is also there, called as by implementing another interface called as callable. Callable is an interface. What is the difference? Why this callable is there, and how it is different from the runnable, and what is the extra benefits of this callable? So for this, if we go for understand differences first. So this is one common question, that the difference between runnable and also callable. Both are interfaces, runnable and callable. What's the difference? The first thing is a runnable interface has how many methods? This interface, according to our previous discussion, I have discussed about it, right? So in runnable interface, how many methods are there? One abstract method is there. Only one is there, right? So runnable has which method? Runnable has a run method, isn't it? And what's return type of this run method? Which returns? What's syntax? Public void run we are using when we are using this approach of runnable interface, right? Therefore, the return type is a void. But callable interface, because it's interface C capital, first letter capital, I mean to say, has a method called as call method. Callable interface has a method called as call. And what it returns? Callable interface call method returns object. So object means what? Any object. It depends on the requirement. Maybe string object, or maybe integer object, or customized object. All those things are possible. So that is the callable. If you ask what is the syntax, public interface name callable, and inside this interface an abstract method. So public abstract keyword is optional, then object is a return type. What's the method name? Call. Any arguments? No arguments. Then abstract methods has to end with a semicolon. So this is the syntax of the callable interface syntax. Yeah. And one more point, the first two approaches of defining a thread, that is the extending thread class and also the implementing runnable interface approach, these are there from Java first version 1.0. But this callable interface is introduced in Java 5, Java 1.5, or we can say it as Java 5. Later on, they come to know that some requirements are not so comfortable with runnable or extended class anyhow. Yeah. So that is when a new concept called callable is introduced in Java 1.5. And this thread class and runnable interface are present in which package? Are we importing anything whenever we define the threads in the previous classes? No. So it is java.lang package. But this callable is introduced in java.concurrent package. That is when there is a concept called as concurrent threads in Java. Java.concurrent package. So in this is introduced. What was the problem with runnable? Let us see that first. Are you getting me? The concern with runnable is, what is the runnable approach of defining a thread? So with runnable approach, what is the syntax? A programmer choice of class, public class, some class A, and which implements runnable. And inside this public void run method only, there is no other option. We have to go for this. And inside this, the task or the logic that this run method has to execute. This is what we'll be writing. So in some scenarios, when multiple threads wants to execute this same run method, multiple threads wants to execute this run method, then what would be the syntax that we will be writing? Of main method, a class test with public static void main, and inside this main, what is the code to generate multiple threads to execute the same run method? So then a class object a1 equals new a of default constructor. The next followed by thread class is required. Yes, some thread t1 equals new thread of a1 object has to be here. Then t1 dot start, isn't it? Start method has the capacity of executing a run method with no arguments of the implemented class. So this is one thread. If the program is executed, child 1 or child 0, first child thread, I mean to say, will execute this run method, isn't it? First child thread. I want one more thread to execute the same run method. What to do? Can we create the object for a class one more time? Yes, for a given class, it is possible to create n number of objects. Then to this A2 reference, can we assign a thread class reference once again? Thread T2 equals new thread of A2 reference. Thread class has a constructor which accepts it. Then followed by T2 dot start. How many threads will execute this run method? Two threads will execute this run method. So T1 dot start, child 0 or first child thread will execute this run method, and T2 dot start also will execute the run method. So like this, for example, like this is any website called Flipkart. Multiple threads to be generated, because when users are accessing your website during some high peak time like festivals and any offers time and all, then too many people will be accessing. It means we have to scale up. Scale up means to provide the service to all the customers. No one has to get the website is busy. Otherwise, the website will lose the significance. Next time, users will not come. Yeah. So in that scenario, so many objects, lakhs of objects will be required. So in that scenario, in that requirement, what is the approach? The programmer has to write how many times? Those many times you have to write, right? So then there is a problem. This is problem in the sense this approach is not so suitable for that. Yeah, that is when a callable approach is required. Hello. Yeah. So then let us see what is the process of a callable. Yeah. So when it comes to the callable approach, syntax or the code. Okay. callable interface approach. Again, because it is an interface, a class has to implement this. So the syntax, a programmer choice of class. Public class, a class name A. And to implement an interface, implements is a keyword. Then the implements interface name, callable. So this time we have to add that import statement of java.concurrent. First part. Is it same? Yes. Then inside this, callable interface has which method? An abstract method called as call method. So then its implementation we have to do it. What is the syntax? Public. Yeah. Is it void? No. What it is? Object. Then what's the method name? Call. And then followed by no arguments. Now is the syntax is right? No. Return type is void or non-void? Non-void. Therefore, what is mandatory? Return keyword is mandatory. So return what object? Any value that you give, it will become type of object. Number, integer object, integer wrapper class. Then if you are giving a decimal, double class like that. So here I am giving something called as say string hello. So this is written. Just for our understanding, when we go for execution of the program, whatever we write the logic here. So here we supposed to write what? What is the logic to be executed? But for us to see, let me add a sample print statement of system.out.println call method is executed. So if you are getting this output, then it is a proof that call method got executed. Is there any difference in runnable and callable except this object and return type? Things are same, right? This part and this part. Here also print run method is executed. Here also if you want to see the result, we can say run method is executed. But because the return type is void, no return statement. That's obvious thing. Any interface which has some abstract methods, the implemented class has to override. Correct? Then the entire difference is there when it comes to the implementation from main method. Which class is required to start a thread? All of you. Which class is required to start a thread? Thread class, correct? So here, let me take test class public static void main method. Inside this main method, first object of this A class, isn't it? There is no change in that. Here also, object of the A class is required. A sum A1 equals new A. So then in runnable interface approach, what's the next part? Thread class we have to use. But here, in callable interface approach, there is no thread class. Thread class is not required here. Then what is required? Here is the next important point to remember. What are the next terminology I am going to use it? All these things are introduced in Java 1.5, same concurrent package only. Yeah. What is the first one? Here, there is a class called as executors. There is a predefined class in Java 1.5 in java.concurrent package called as executors. What is the purpose of this class? This class has a method. Previously to generate multiple threads. So here we are writing the multiple times thread object and which is integrating or connected to the implemented class reference. But here directly we have a method called as new fixed thread pool. New fixed thread pool is a method. So it means we are generating the fixed number of threads for the requirement. For example, during a normal day, yeah, a Flipkart website requires some 1 lakh threads enough. At a time, 1 lakh. But during festival days or any offers days, I need some 10 lakh threads. So that every customer will get the service from the Each thread will serve them. Yeah, that is where thread pool. So for load requirement, we can go for some small number, say some 10 or 15 or whatever. Just example I'm giving. You can give any number. Integer is input. Minimum 1. We can't give 0. We can't give 0 because generating 0 threads, it's meaningless. So it should be 1 is a minimum, maximum up to integer range. 2 lakhs, so and so, this and that. Okay, we'll see that. What's the return type? If it is long, then some more values also we can give. So this is the method. Executors class has a static method called as new fixed thread pool. We can give the number of threads required to be generated. And this will give one more class called as executor service. Executor service. Some reference, SER service. This executors dot new fixed thread pool method will give a class called as will give the reference of executor service, will return this object. Yeah. So then by using which object we have to call? SER dot which method we have to call? Submit method. Here is a submit method. On this service object reference, we have to call a submit method. This will take this object reference called as A1. So far, we didn't connect our implemented class to this any of the executors or executor service. So this is where this will be. What this will return? This will return one more class called as future class object reference. Feature sum F. So this is the callable approach. So executors dot new fixed thread pool of number of threads that we can give as input, minimum 1. And the return type of this executor dot new fixed thread pool is executor service. It is also a predefined class present in Java 1.5. Okay. So then this service object has a method called as a submit method. We used to call start method on thread object, but now service object reference, executor service object reference has a submit method like start method. Submit method has a capacity to execute the callable implemented class thread reference, and that will return a future class object reference called F. Now, if we execute this code, we get the output as call is executed. This method is executed. So because of this line, so this method will be executed. So that will give the output of this call is executed. Did you understand? Yeah. So then how come it is solving the problem of multiple threads to execute the same thing? So previously, when multiple threads wants to execute the run method, then each time you have to generate a new thread reference for the implemented class, and we have to use start those many times. But here, so once we have this one, how many threads we have in thread pool? 15 threads, right? Then if at all we want 15 threads to execute, we can go for a loop. For loop, int I equals 1 to start, I should be less than or equals to 10, then I plus plus inside the loop. Now what will happen? Out of those 15 threads, according to the thread schedulers scheduling process, any 10 threads will execute this call method those many times. Each thread will execute the same call method. Any 10. Possible? Yes. What if I go for 20? I'm executing this submit method means I want to execute this call method by 20 times. Possible? Absolutely possible. That's advantage. Now, for example, number of threads in thread pool are 15. But how many times you want the call method to be executed? Or how many customers will approach the Flipkart? More than the thread pool. Then what will happen? One thread who finished the job. Yeah. So for example, 15 threads will execute the call method because the thread pool has 15 threads. Once the first thread finishes its job of executing this call method, now it's free. So it will come and serve once again, 16th one. 16th service is the first thread. 17th service is the second thread. Like that. Again, thread scheduler will take care about all those things. So in this way, by generating the number of thread pool, we can serve the purpose depends on the requirement, even though the requirement is more than the thread pool. Here, if we can write 100 also. It means what? Each thread has to execute 6 times, 15, 6, 90. Again, some more, 10 more threads will have to execute 7th time also. So that's how all these 100 purposes will be served. Are we generating multiple? So this is what the code is easy. What about in this previous scenario? 100 times run method has to execute. What we should do? 100 times thread 1, thread 2, thread 3, thread 100. So that's a lengthy code. But this is the solution for such type of requirements. That is when callable is introduced. Is it understood? If at all we want to see this method is having some business logic or some logic and also returning something. Can we see this returning something also? What it is returning each time? Hello. How to print that? When something is returned, we can print. How to print? Submit method has a method called as get method. Submit method, again like next dot char to read a character. Similarly, submit method dot get method is there. And here, if you are going for a toString, object class method called toString will print the class object which is returned. In print statement, we can print this. Submit dot get and then dot toString. Hello? Yeah. Sorry. Sorry. This is not submit. This is f dot. Future class reference. In this, the return value is there. No? F dot get dot toString. So this is the approach. If at all we want to print this, what is the return type? Then this is the approach. No, method execution is enough for me. Return value is not required for me. Then ignore this line. Hello? Yeah. So this is the syntax and this is what is recommended and this is what is used in real-time scenarios. No in extending thread class approach, no implementing runnable interface approach. So we'll go for the execution of the same thing. So for this, in project SRC in threads, so let me go for new class, a callable demo. So I'm considering a main method here. So let me double click to expand. So then followed by inside this default line is not required. Next, first we need to consider a class which has to implement the callable. Syntax please. Class of programmer choice. Let me take the class name as A, or A might be there in one of my previous programs. Let me go for something as example. Okay, first let me try with A because handwritten code and this will be in sync. The keyword implements which interface? Callable. Control space. You can see what is the package name? java.util.concurrent is a package. Yeah. So this generic type not required. So this is a class which implements. So this says that A class is already there. Yeah. Or first let us try the implementation of the callable methods. Otherwise this class cannot exist, right? So when a class is implementing an interface, class has to override the methods. Control space, which method? Call method. So let me override. So there is no problem with class A. So this overriding. So is annotation is mandatory? Optional. So let me remove that. Inside this call method having a return type of null. So null is also one of the object. So if you at all you want to change this, you can change this to any type, Okay. So I am just changing to hello as per my handwritten code. And just to observe or to get some output whenever this call method is executed. So I'm just printing some sample message called as call method is executed. So this is the normal syntax when we implement an interface, override the interface methods. But when it comes to the execution part, that's where more focus is required. And here, what is the process? Which class we have to use? Executor, isn't it? Control space to import from java.util.concurrent. Executors dot which method? New fixed thread pool. What's input? Int number of threads. So here, this is the method. We can take any number. So depends on the requirement. So if you just notice the return type, what's the return type? Executor service. You can use any reference. So I'm using SER as a service. Or you can go for any variable, X, Y, Z, ABC. So then before this, what we have to do? A class object is required. The order can be anything, of course. So just to keep it simple. So before we go for getting the number of thread pool, we are creating the A class object, which is implemented class of the callable. What's next part? By using this SCR object reference dot which method? Submit method. Submit method is expecting what? Callable T. So which is that? A1. Right? So this is the syntax to execute a call method. So when it comes to runnable interface, start method from thread class has the capacity to execute the run method. But service class reference of executor service class reference called SER has a method called as submit, which has the capacity to execute call method of callable, implemented class of the callable method. So now with this syntax, let me go for run the Java application. So we got the output. Call is got executed. Yeah. So then this is the one. What if the same thing we have to execute by multiple number of times? So that is when this syntax we can write inside the loop. A for loop int I equals 1. Previous approach of generating multiple threads to do the same job is a different thing. 15 then followed by I plus plus. Even the thread pool is size of 10, but I'm going for 15. So then 15 different threads has to execute this submit method. 15 threads has to execute. Control yes, control F11. So how many times? 15 times. But how many threads are there in thread pool? 10. But some are working, some threads are working more than once, depends on the requirement. How do we understand? We can print call thread is executed. So then let me concat a string by space. Okay. I want to print the thread name. Which thread is executing what time? Okay. How to print that? How to get the thread name of the current class? Thread dot current thread dot get name. Control yes, control F11. We can see how many threads are there. 10 threads are there. So 1 somewhere because random order. Then 2, 3. 3 is 2 times. 4 once, 5 once, 6, 7, 8, 9, 10 got twice, 3 got twice. Yeah, like that. 5 got twice. So some threads are working overtime to fulfill the job of executing the same thing for 15 times. So this is the approach of callable. So then one more point, how do we print this return value? Along with the execution of this one, how to print this return value called hello. So this submit method has a return type of feature reference, feature sum f. So by using this reference f of a feature class dot get method dot to string method from object class. Now the same thing we can see, control F11. So I supposed to save something. Just a second. Yeah, so this is whenever we call a method, so it is throwing some exception. Let us use try catch for it. So control yes, control F11. So you can see each time we are getting the return value also. Whenever that method is called, method return value also. So we are getting as a result here. So hello, first time thread 1, thread 2, thread 3, like that. So here it looks like the order 1, 2, 3, 4, 5 up to 10. Again 1, 2, 3, 4, 5 threads are working. So it's no guarantee that every time it's the same output, because randomly they'll work. So if we re-execute, looks like again same. So this time again same. Yeah, it depends on CPU's time allocation, all those things. Yeah, fine. Then so am I clear with this, or do you have any questions or doubts? So why that sequence? It is because of the order of try catches. So throws some exception. Now I'm avoiding that exception. So I'm not using any try catch. This time you see, you'll get the difference. 1 to 10, re-execute. Okay, probably same. Don't know. It's random. Already we have seen without this printing this get to string method. So if we comment this, already we have seen that flow of execution. So this is where again you see some random. Okay. So this is about the callable. Is it understood? Or do you have any questions? Just please let me know.